Welcome back to class. Today, we are moving forward in Chapter 8, Rational Expressions and Functions. In this lesson, we will focus on the first three core areas, Section 8.1, Rational Expressions, Section 8.2, Multiplying and Dividing Rational Expressions, and Section 8.3, Adding and Subtracting Rational Expressions. Let's master these foundational algebraic concepts. A rational expression is any expression that can be written in the form of a fraction. This means it always has a numerator and a denominator. For example, look at this form, p over q, where q cannot be 0. An expression is undefined if the denominator is equal to 0. Let's look at an example. Determine the value of x for which the expression 5 over x minus 3 is undefined. It is undefined when the denominator, x minus 3, equals 0. This means that the expression is undefined when x equals 3. Let's look at another example with a quadratic denominator. Determine the values of x for which the expression 4x over x squared minus 3x minus 10 is undefined. To solve this, we first need to factor the denominator. The quadratic expression x squared minus 3x minus 10 factors into the product of x minus 5 and x plus 2. The expression becomes undefined when the denominator equals 0. This happens when either x minus 5 equals 0 or x plus 2 equals 0. Therefore, the expression is undefined when x equals 5 or x equals negative 2. Let's look at an example with rational expressions containing a variable. Determine whether the expressions 3x over 4 and 9x over 12 are equivalent. To test equivalence, we can use the cross-multiplication rule. The expressions are equivalent if the product of A and D equals the product of B and C. Multiplying 3x by 12 gives 36x. Multiplying 4 by 9x also gives 36x. Since both cross products are equal to 36x, the two expressions are equivalent. A rational expression can be written in its lowest terms by reducing it to the simplest equivalent fraction. This is done by factoring both the numerator and denominator, and then canceling out the common factors. Let's practice with an example. Reduce the expression 42 over 48y to its lowest terms. First, find the greatest common factor of 42 and 48, which is 6. This means we can rewrite 42 as 7 times 6 and 48y as 8 times 6 times y. By canceling out the common factor, 6, we get the simplest equivalent fraction, 7 over 8y. Factoring both the numerator and the denominator is the absolute key to solving more complicated rational expressions. Breaking it down into its factors helps us easily spot the common terms that can be canceled out. Let's solve a new example. Simplify the expression x squared minus 16 over 5x minus 20. First, let's factor the numerator. X squared minus 16 is a difference of squares, which factors into x minus 4 times x plus 4. Next, the denominator, 5x minus 20, factors into 5 times x minus 4. Notice that x minus 4 is a common factor in both parts. By canceling out x minus 4, we get the final simplified result, x plus 4 over 5. Now let's move on to section 8.2, multiplying rational expressions. To multiply two rational expressions, we simply multiply the numerators together and multiply the denominators together. However, it is always best to factor and cancel common terms before multiplying. Let's look at an example. Simplify the product of xy over 3x plus 6y times 4x plus 8y over x squared y. First, let's factor everything. The first denominator factors into 3 times x plus 2y. The second numerator factors into 4 times x plus 2y. Now, we can cancel out the common terms. The group x plus 2y cancels out completely. 1x and 1y from the top and bottom also cancel out. After multiplying the remaining parts, we get our final answer for over 3x. Let's tackle a more advanced problem. Simplify the product of these three rational expressions. It looks intimidating, but the strategy remains exactly the same. We will factor every single numerator and denominator first. To solve this, let's factor each part step by step. Notice how the quadratics factor beautifully into linear binomials. The grouping method in the second denominator gives us x plus 3 times a minus 2. After writing everything in factored form, we can cancel out all the common factors. The terms x plus 2, x plus 3, and a plus 3 cancel out from the top and bottom. Finally, we are left with the simplified equivalent fraction, a plus 4 times x plus 5 over 2 a minus 1 times a minus 2. Dividing by a fraction is the exact same as multiplying by its reciprocal. For example, let's think about dividing 12 by 1 over 3. This asks, how many thirds are in 12? The answer is 36, which is equivalent to 12 times 3. We can extend this exact same concept to any rational expression. To divide m over c by b over v, we flip the second fraction to its reciprocal, v over b, and change the operation to multiplication. This gives us the final multiplied form, mv over cb. Let's practice dividing rational expressions with polynomials. Simplify the expression x squared minus 9 over x squared minus 4x plus 3 divided by 3x over x minus 1. First, rewrite the division as a multiplication by the reciprocal of the divisor. So we flip 3x over x minus 1 into x minus 1 over 3x. Next, factor all numerators and denominators completely. X squared minus 9 becomes x minus 3 times x plus 3. The quadratic denominator factors into x minus 3 times x minus 1. Now, cancel out all the common factors. The groups x minus 3 and x minus 1 cancel out completely from the top and bottom. Finally, we get the simplified result, x plus 3 over 3x. You can divide any number of rational expressions at once. If there are no parentheses, you must always calculate from left to right. This means each division turns into multiplying by its reciprocal step by step. Let's look at an example. Simplify this long string of divisions. First, rewrite each division as a multiplication by the reciprocal. The second fraction flips, and the third fraction flips too. Next, factor all numerators and denominators completely to see the factors. Finally, cancel out all the common factors from the top and bottom. After dividing out the identical terms, we get the beautifully simplified answer, 3 over x plus 1. You can multiply and divide rational expressions at the same time. Again, work from left to right. Wherever you see a division symbol, change it to multiplication by flipping that specific fraction to its reciprocal. Let's solve the example. First, rewrite the division as a multiplication by the reciprocal. Notice that only the third fraction flips. Next, factor all numerators and denominators completely using quadratic methods. Finally, cancel out all identical common factors from the top and bottom. After dividing out everything, we get the beautifully simple answer, x over y. Welcome to section 8.3, Adding and Subtracting Rational Expressions. To add or subtract expressions with the same denominator, simply add or subtract the numerators and keep the common denominator. For example, look at these general algebraic rules. Let's practice with an example. Simplify the expression x plus 3 over y plus 3x minus 7 over y. Since the denominators are both y, we can add the numerators directly. Combining the terms gives us x plus 3x minus 7 all over y. Next, combine the like terms in the numerator. X plus 3x equals 4x and 3 minus 7 equals negative 4. This gives us our final simplified answer for x minus 4 over y. Let's practice subtracting rational expressions with a common denominator. Subtract and simplify the expression for x plus 2 over x squared minus 16 minus 3x plus 6 over x squared minus 16. Subtract the numerators and keep the common denominator. Be very careful to put a parenthesis around the entire second numerator so the negative sign distributes properly. This gives us 4x plus 2 minus 3x minus 6. Combining like terms simplifies the numerator to x minus 4. Next, factor the denominator. X squared minus 16 factors into x minus 4 times x plus 4. Finally, cancel out the common factor, x minus 4, from the top and bottom. We get our final simplified answer, 1 over x plus 4. When adding fractions with different denominators, you must find a common denominator first. Simply multiply the denominators together to get the common base. Then, convert each fraction into an equivalent fraction with this new common denominator. Let's look at an example. Add 3 over 4 and 1 over 7. Multiply the denominators 4 and 7 to get the common denominator, 28. Convert the first fraction by multiplying the top and bottom by 7, which gives 21 over 28. Convert the second fraction by multiplying the top and bottom by 4, which gives 4 over 28. Now that the denominators are the same, add the numerators. 21 plus 4 equals 25. Our final answer is 25 over 28. Let's practice subtracting rational expressions with different numeric denominators. Subtract and simplify the expression 3x minus 2 over 3 minus 2x plus 4 over 4. First, find a common denominator by multiplying 3 and 4, which is 12. Convert each fraction into an equivalent fraction with 12 as the denominator. Multiply the first fraction by 4 and the second fraction by 3. Now, combine them over the common denominator 12. Be careful to distribute the negative sign into the entire second numerator. This gives us 12x minus 8 minus 6x minus 12. Finally, combining the like terms gives us the answer, 6x minus 20 over 12. We can factor out a 2 from the top to reduce the fraction to 3x minus 10 over 6. To add or subtract fractions with different denominators efficiently, we need to find the least common multiple, or LCM, of the denominators. First, factor the denominators completely. Then, multiply together the highest power of each factor that appears. Now, let's look at the 4 steps to add or subtract fractions with different denominators. Step 1. Find the least common multiple of the denominators. Step 2. Convert each fraction into an equivalent fraction with the LCM. Step 3. Add or subtract the numerators. And Step 4. Factor and cancel any common factors if possible. Let's solve an advanced problem combining addition and subtraction. Simplify the expression 3 over 2x plus 4 plus 2 over 3x minus 3 minus 4 times x plus 2 over x squared plus x minus 2. First, factor all the denominators completely to find the least common denominator. The denominators are 2 times x plus 2, 3 times x minus 1, and the product of x plus 2 and x minus 1. So, the least common denominator is 6 times x plus 2 times x minus 1. Convert each fraction using this common denominator and combine the numerators. Distribute the numbers and combine the like terms in the numerator. This simplifies to 13x minus 25. Our final simplified answer is 13x minus 25 over 6 times x plus 2 times x minus 1.